All right, thanks so much, Ryan, and thanks everybody for coming out. It's really good to see you all here. So basically what we're hoping to do today is talk a little bit about and share some best practices around what we've learned in the process of using Jupyter Notebooks to basically teach everything that we teach at the Data Incubator. So what do we teach? This will be the combination sort of context setting and shill for our company. We teach a variety of different classes. The first thing that we started was an 8-week fellowship program for folks with advanced degrees who want to leave academia and make the transition into industry as data scientists. That's what we're best known for, and that's kind of where our curriculum was initially developed. The sort of next group of people that we're teaching to are people who want to learn kind of the basics of data science. This is more of a public-facing course. We're calling it the Foundations course. So to these folks, we'll be teaching somewhat more, foundational stuff, NumPy, Pandas, even introductory Python in that context. So both of those courses also run over a slightly longer time frame. The fellowship, again, is 8 weeks. Foundations is a similar length of time, just part-time. And then the other sort of two things that we do in terms of teaching are corporate trainings. So those are 2 or 3, like 3 to 5 day, I'd say, workshops. Rob does a lot of corporate trainings, far more than I do. But and that really runs the gamut of interest levels. We'll basically take pieces of our curriculum and deliver those in a short, very focused setting. Similarly, we'll run workshops at conferences like these. We ran a TensorFlow and practical machine learning workshop. I see a few faces from that training out in the crowd here. But again, very focused, short-term kind of engagement. So we have all this different content for these different groups of people. We're teaching it over different time scales, but for all of these sorts of different learning environments, we're still using the same platform, the Jupyter Notebook. So we're thinking about this talk as being divided into 2 different parts. The first part is what we do inside of notebooks to facilitate learning, and Rob's going to take that part of the talk. And then the second part is going to be what we do around notebooks to facilitate smooth delivery, deployment, and development of all of our curriculum materials, making sure that's all good to go. And I'll be speaking about that. So Rob, I'll let you take it away with the stuff inside of notebooks.
Thank you. So as Christian said, we use notebooks. We use notebooks for everything, including this presentation. But in teaching, there's sort of 2 main areas we use them. First is when we're lecturing out of notebooks. The curriculum is in there, and not only does the teacher have it, but the students have the same copy, so they can follow along, play with things in there as well. And then we use it when we give the students exercises. Those exercises are given to them in the form of notebooks so that they can code their answers right there. So I'm going to tell you a little bit about the things we do with both of those. So for teaching, we love notebooks because they allow you to teach in many languages with about the same interface. Most of our stuff is done in Python, so of course we're using IPython. But we also teach courses in Spark and Scala, so the Tori kernel helps us out there. We're teaching a course in R, so the R kernel is great here. And if you've looked at the list of kernels available on the wiki, it's impressive. One thing we haven't found there, though, is a web kernel. We do teach a little bit of the web stack, some HTML, JavaScript, D3 type things. And we wanted a way to show this in the notebook as well. And IPython itself has some magics that help you do this. So you probably have seen these before. If not, there's the HTML magic, which just puts HTML on your web page or into your notebook. There is a JavaScript magic that just lets you run JavaScript right there. Nice, easy enough. But there is a slight problem with them, and that is that all of this stuff is being done within the context of the notebook document itself. So that means, for example, you can do things like this. I avoided putting the MIDI music in the background, but and actually, the problem isn't that direction as much. The problem is more the other direction. If we're trying to show a basic idea of JavaScript or CSS or HTML, you're competing with the existing definitions in the notebook namespace. And that can be a little bit confusing for those people who are coming to the HTML development new. So we want some way to isolate our context from the notebook context. And the way you would do that, of course, is iframes. Whoops, I do want to say before we get to that, we have a previous solution. Some of you have seen it. This is one of our more popular blog posts, coming up with a pure JavaScript solution for inserting documents in there. But it doesn't really help people look at and understand how you build these in a standalone setting. So what we decided to do was we looked at iframes. Iframes allow you to isolate a certain amount of web content from the surrounding web page. And there's not much for us to do, really. It's already built into Jupyter. All you have to do is call iframe with a URL, and you get that website included right there. Very easy. But there is a slight problem. Namely, the thing you pass into the iframe is a URL. And we want to just be showing HTML code there. But there's another tricky web thing that some of you are probably familiar with, data URLs. So usually a URL is telling you where to find some content, but data URLs include the content right in the URL itself. Usually you're using this to put little small images on a web page where the overhead of another HTTP request outweighs the overhead of base64 encoding, but there's no reason to limit yourself to that. So just to show you how it works, there's a simple data URL of a small PNG image. But you don't have to use that just for images. You can use a data URL with HTML content. So here we're just going to base64 encode some HTML, stick that as a data URL in an iframe, and voila. And you notice now I can do things like modify the background color of the document, and it's trapped within the iframe. It does not escape into the notebook content. So we've written a package to manage this. We call it iHTML. It just does these things together and gives you a nice little IPython magic that now lets you put content into its own iframe where it's not going to disrupt the rest of your notebook. A couple other things we did to this. Usually, we're not just making HTML. We're showing how you interact with Python. So you have some data, and then you want to put that onto a web page. So we've written a little templating language in here, inspired by Jinja, where you can just use this double curly brace notation to put in any variables you want. You can put them in raw, or you can format them in JSON so they show up nice and neat, and they just work. So this is very nice for displaying HTML, but web development isn't just about HTML. There's also CSS and JavaScript. And we want to give people an idea of how you should start structuring your web things. And you should have these in different files. So we've made these sub-documents as well. You have a CSS document or a JavaScript document where you just write your CSS code or your JavaScript code. When you execute it, nothing happens. It's just storing that information in a dictionary being held by HTML. And then when you want to use that, well, we'll just hijack this Jinja notation before and put these documents in. So this isn't quite real HTML. We're not having references to other documents there. It's all being turned into inline elements. But it's at least enough to give people the idea of the general structure they should be approaching. And in the end, you get a document that is completely isolated, but still completely interactive in there. So this is not going to replace your web development platform, I don't think. But we find it's a good tool for teaching, and it's actually occasionally handy when you just need to try these one-off things in your notebook. It is up on PyPy, at least as of an hour ago, so hopefully it works when you try downloading it. Also available on GitHub, and we've released it under the BSD, so please try it. Let us know if it works or if it doesn't, and we'd like to make this useful to everyone. So it's great having all of these kernels, and usually they do what we want, but sometimes we might want to tweak them a little bit. For example, one thing we ran into was exception handling in IPython notebooks. So this is what happens, and frankly, it's great when you're teaching. You get these lovely tracebacks that are all colored, so you can point out what's going on and help your students understand what's happening in the call stack. But there are two problems with this. The first is we like to test our notebooks. And if a cell is throwing an error, usually that's a bad thing. Usually that should cause a test to fail. So we need some way to note in our notebooks that this is a problem that's supposed to happen and shouldn't stop our testing. And the other problem is sometimes you need to start a notebook halfway through, and you want to run all of the cells up to that point. but exceptions cause notebook execution to stop. So if this is the case, then you're in the middle of the lecture, you had to restart the kernel, you have to go back and find all these places that were supposed to raise exceptions and restart execution after them. So what we wanted was a way to sort of disable this blocking behavior of exceptions while leaving this traceback display, which is so useful for students. And the old way we did this was with try except blocks. This is how you write Python when you're expecting exceptions, right? So we just put that in there. You could print out a little bit about it, which is fine, but it doesn't help students learn to read tracebacks. And this is something that we've noticed is actually a big hurdle to overcome. Something goes wrong, you get this big blob of text out. How do you look through that and start to understand what you did wrong and how to fix that? So we wanted to be able to leave these tracebacks in place. And we tried a couple of things to do this. One is you can just put the traceback in there in Markdown directly, cut and paste it from your another thing, which works. But if you're doing this, you've lost the whole point of Jupyter Notebooks, which is this wonderful interactivity where you can demonstrate how things go wrong and then demonstrate how to fix them. So this isn't so great. We tried an early attempt here where we would just do some syntax level rewriting. So we can write a magic like we did before that will take some code in, and we can put that code in a try except block. And then if there is an exception, we'll just go ahead and load the same traceback formatting that IPython uses to produce that output ourselves, but because the exception is caught, it won't stop execution. This actually works. I don't have that magic here, but this is what it will do. It gets you that exception. It doesn't block callback. If I tried to keep running, it would just keep running the next cell. But it does mess up the display of the code because you're inserting additional code there. As far as the kernel is concerned, you got that whole try except block, even though that's what was added by the magic. And that's not so bad. I was about ready to go with this, but then I was digging a little bit deeper. And I realized that magics can actually interact with the Python shell itself. So the magic classes get a reference to the current shell, and you can do all sorts of things to it in there. One of them is that there's this set custom exception function where you can pass in a custom exception handler and tell it, you should do something else with this exception. So we built one that goes in, catches the exception, prints out the traceback just like IPython was, but doesn't halt the execution. We're calling this ExpectException. So if you import that, it gives you a magic. This looks like what you'd have without it, but it doesn't block the execution. So our test will continue just through this. They know it was coming. If I need to re-execute the whole notebook, this won't stop it. As you saw before, you can specify an exception that you're expecting. If you leave it out, it'll just catch anything of that subclass's exception. And if you're expecting an exception, if you don't get one, that should be a problem. So if you expect an exception and an exception doesn't show up, you get an exception expected exception. I said it, which lets you know that something went wrong. So this is actually reassuring in testing. We can write code, and if it doesn't break, we know it's broken. Sometimes you run into a case where sometimes you expect an exception, sometimes you don't. For example, if you're hitting an unreliable web resource. So there's also this IgnoreException, which if there is something there, it will just keep going. If there isn't, that's also fine. And one last thing to show off, we leave the debugger working with this. So if I ask it to debug, it's finding that exception that was caught by my machinery. It's still there for us to explore, so you can still go ahead and look at anything in there. It just works. So this too is up on pip. It's on GitHub, BSD license. So if this would be useful for you, please take a look and let us know how it works for you. So that's a little bit about the tools we try to use when we're teaching from notebooks. But we try to avoid spending too much time lecturing people because the way you learn is by doing. The way you learn is by working on these exercises and getting the code under your fingers. So in most of our trainings, the majority of this time spent by students is spent working on what we call mini projects. And these are sort of short projects that should take several days where they're doing analysis of real-world data, actually understanding how this works in real life. And what we tend to be worried about when we're teaching is not so much the details of how they implement things, but do they manage to find their results? If they go approach A, approach B, approach C, we don't care too much. We care that they've managed to figure out how to get results out. And that affects how we set up these sorts of notebooks. So each of these shows up in a notebook. We love these because they allow us to mix the description of the problem, some helper code, as well as an outline of the solution, all in a single document. And we'll start off with sort of simple fill-in-the-blank type questions. So this is one we actually pulled from one of our notebooks. And literally, we're telling them, hey, you should write a line of code here that updates one dictionary. You should write another line of code below it that updates the next. And what we find, people who are unfamiliar with Python, who are just getting used to the language, really like this hand-holding in the beginning, because otherwise you give them a blank cell and it's a little bit of panic time. So we try to get them started out, but very quickly we try to move on to questions that are a bit more broad, allow them to explore a little bit more. So this is that same notebook. By the end of it, we give them this text description of what to do and an empty code cell, and they're expected to be able to go figure it out from there. In each of our mini projects, we'll have somewhere between, 3 and 10 different questions that they're supposed to answer. And these are trying to build on each other. They're trying to drive towards a final point. But sometimes students want a little bit of hand-holding in between. Am I on the right path? So what we've been doing, and this is not a perfect solution, we don't think, but it's working pretty well, is to put assert statements in there. If we can help them on the way, check, did you get all of the cities that you were supposed to find in this case so that you have the right length of your data? One thing I've noticed here, one warning for you, is that students are clever in the ways they solve things, and they will solve things in a perfectly fine manner that breaks the assumptions that are going into these sorts of assert statements. So watch out for that. This is something we're thinking about, and maybe we'll be back next year and tell you a better solution than these assert statements. So I said we have a number of different questions we ask them to solve. And the way we can tell if they solved it is we've built an automated grader. And the idea is we want to be able to give instant feedback to the students based on the results of their analysis. So students are going to write a function that returns an answer. And then when they pass that function to us, we'll run it and see what the answer is. This is a bit different from NB grader or the OK grader that other people have been using in two major ways. First, the teachers do not get the code. We'll be wandering around, we'll be talking to students, but we don't get a final submission of the code. So that's the downside, but the upside is the students get immediate grades in seconds. They submit it, they get an answer back, they can iterate on that, try to improve it, and understand what they're doing right and wrong very quickly. Sometimes these questions are asking for a fixed answer. So here's a simple one. Just give me a list of the first 5 prime numbers. So we're at a function that returns that list. We pass it into the grader.score. In this case, I don't know my prime numbers very well, so it turns out 9 isn't one. If we change that to 11, now I pass. We use this mostly for our data processing questions. Hey, go find the top 100 X in this large data set. Give us a list of those. Sometimes, however, we want to have questions where there are sort of dynamic answers. For example, we could ask someone to build a function that takes a list of numbers and returns a list of squares. So this is why the thing we're passing to the grader is a function, because we want to be able to give this input. And we use this typically on machine learning type problems, where we'll ask them just to build a machine learning model. We'll give them some test input. They'll give us back their predictions for that. We'll use some sort of metric to see how well they did, and then we just compare that to a reference solution we wrote. A little bit about how this works. So one of our developers, Christian or myself, or one of the others, will define a problem that involves writing both the notebook and a description of what the solutions look like. So the notebook goes out to the students, and Christian will tell more about how this works shortly. The problem description, which is just a JSON document, gets shipped off to the grader machine. And then when the student's ready and they hit that grader.score function, they pass the problem name to the grader. The grader will look up that problem, return with the input to that problem. The student machine will run the code, so they don't have to worry about anything with dependencies or versions. Whatever was working on their machine will work when the code is submitted. They ship the answer back to the grader where grading is done, and then the grade goes back to the student as well as into a database so that we can look up it later. One last thing, people want solutions at the end. So we have this notebook that sets them up. We also want a notebook with the solutions together. And we want to make sure these stay in sync. We don't want to have to keep updating them side by side. So we generate both the prompt notebook and the solution notebook from the same document, just using a very simple templating system. So it's an example of what that might look like here. So when we're generating the prompt notebook, this is telling us to take out some lines, to add in other lines, often removing the right-hand side of expressions so that we know what their variables are named, but they have to figure out what data goes into it. And then a preprocessor script can just strip out the appropriate things to leave them with something like that later cell. And then when we generate a solution, all you have to do is go move those comments, basically. So the executable code is exactly the same between the solution notebook and our working notebook. And that means we don't have to worry about doing any preprocessing before we test. It's only just before we distribute it. One last point on this is mini projects aren't always right. We found for sort of smaller training events, it's better just to have exercises within the notebooks that you're lecturing from yourself. So you can take that 5-10 minute pause, let people work on something, and then give them immediate feedback. If you don't have this several-day period to work with them, that tends to work better than having a completely disconnected mini project. So with that, I'm going to hand it back over to Christian, who'll tell you how we actually get all of these things out to students.
Thank you, Rob. Sure. So the question now is sort of what does our development flow look like? So we just talked about how students interact with this. How does the development side work? How do all of our course developers, we have maybe 5-6 people working on these notebooks, how do we make sure that the content stays relatively standardized, it stays relatively clean, and how do we make sure that we can collaborate all together on all this content that we're developing? So we use Git and GitHub, so we sort of use a pull request style development model. But one of the things that exists in .ipynb file output that we don't necessarily want is the output from each cell that you run. So you can imagine when you're trying to look at someone's changes, or maybe you've done this before yourself, but when you see all of that output data, it completely clogs up any hope that you might have of looking at a Git diff and seeing something sensible. It's already kind of tricky with the JSON in the first place, right? But when you have all this really messy output, it's tough. So we like to clean that out and sort of remove that, right? So our history looks clean. It's also nice for students because that means that the notebooks themselves are in a blank state when students get them. And then they will be running the code for themselves and kind of having that output appear rather than seeing it already there. So we have a really simple solution for this. Git lets you write pre-commit hooks. So as soon as you type git commit before the files in the staging area are actually committed, we execute a Python script. And the gist is here. Our talk is up online. We have the link for the talk later. But the gist is in here if you want to take a look at the whole script. This is really the most salient point. It's quite simple. All we do is sort of load up the IPython notebook using importing nbconvert. Then in each of the output fields of each cell, we just clear that, make it blank. And we also clear out that little execution count thingy that you see so that the notebooks are in a clean state. So we've been thinking about also developing this into an extension where this would happen on save. So if anyone's interested in that, please reach out. It's currently something that we're kind of thinking about, wondering if that's useful. So let us know. We'll have our contact information at the end as well. So that's kind of the first piece of the development pipeline that happens. We want to make sure our notebooks are clean. We also want to make sure that our notebooks work and that they run. So our solution for this is relatively simple. It's the equivalent of going up to the top of the notebook, clicking what is it, kernel run all cells, or run all cells, but the run all cells button that you can click, and making sure that we get all the way to the bottom of the notebook without any exceptions being raised, without anything bad happening, and kind of making it all the way. So it's quite easy to script this with the mbconvert command. So the blog post here is a little bit longer, but you can use this. You can imagine iterating over all your notebooks, running this mbconvert command, and making sure that you get a final output. And this just works. It's really wonderful. As long as you're in an environment with any kernel, as long as that's installed, mbconvert runs. It runs great. We use it for Spark. We use it for R. It starts up the whole Spark context. It works in parallel. It's great. So that's sort of invariant one that we want to maintain. All of our notebooks, if you click run all cells in the right environment, should just run. Invariant number 2 is we want to make sure that all of our links work. So any external resources that we're providing to students, any cool slides or external reference material, we want to make sure that that stuff is up and live. I don't know, maybe a year ago, scikit-learn completely changed all the URLs for their documentation, and we had to go in and change all that. And we were notified of that because of this test that we run once a day, basically, to make sure that all of our external sites and our links in our content to external sites are live. The other piece of this is internal links. So if we have notebooks that reference other notebooks, we deploy our content in a variety of ways in a variety of different packages. But have about 100 different notebooks that go into these various packages, right? There's a different package for the foundations people that includes some content on pandas. We also provide that during the fellowship to make sure that people have a baseline for pandas as they move into the more advanced stuff. So we want to make sure that we deployed all of the correct resources. If our pandas notebook links to something in the NumPy notebook, we want to make sure that the NumPy notebook is also there. So we have a little bit of checking around that as well. So those are some of the notebook invariants we want to maintain. And the last piece that we want to make sure works is the environment itself. We sort of take care of that, right, by executing all the notebooks. But we also have to make sure that when we have developers working on this stuff, that they can pretty easily go in and modify the dependencies. And it was actually awesome hearing the Data 8 talk yesterday, where they were talking about how they've done a really similar setup to what you'll see that we've done. It seems like it's an emerging best practice to allow course developers to modify the environment as needed, and giving them a simple flow where they can do that. So what does that flow look like for us? Well, here it is. And you kind of want to start up in the top left. This is kind of what it looks like from the course developer's perspective. So they modify the notebooks or the environment. It's all in the same repository. So you can imagine they might change. We use Anaconda, the environment.yaml file, or maybe they need to include a new Spark dependency, something like that. Really easy to do in the environment. If you can script it to be installed, then it can be installed. Once they've made all the changes they need to make, they'll do a commit. The commit hook will clean out all of the output. They then just push their code up to GitHub, make a PR, and that triggers our CI server. So at that point, our CI server will check to see if the environment has been modified. And basically, right, it will handle the entirety of this sort of test to deploy pipeline all on its own. So that's really, really powerful for developers, and really empowering as well. So at that point, we just make sure to rebuild a new image if the environment has been updated, and then run all of our tests that I just described in that environment. So you can imagine here, if this fails, the development cycle kind of just goes back up to the top. The course developer makes any modifications they need to make things work, pushes it back up, CI runs again. Once we get the sign off and everything seems to be working, we merge that in. Our master build will then just make sure everything works again in actually a slightly different environment. It will package up all the notebooks into the appropriate folders. We call them modules that the different notebooks get deployed into for the various courses that we're doing. So it will test them in an environment as close to production as possible on a CI server. Once that build passes, we deploy two things. So if the environment was updated at all, we push out a new base image to DigitalOcean, which is the way that we're currently providing the environment for our students. They each get one little DigitalOcean box. And then we'll also push out the new materials to S3. So this is great, right? We have lots of testing. Developers all they have to do is push something, and the rest is kind of taken care of for them. And we'll see kind of the other side of this diagram in just a minute in terms of how this new base image and this new content can then go out to students. But first, one quick thing I want to mention is this can be really slow. We have, how many notebooks do we have, Rob? Like 100, 120, something like that?
A lot.
A lot. One time, I actually ran a little NB convert script, turned the files into PDFs and did a page count. And it was, I think, 400 to 500 pages of content without the outputs. And we have a lot of images and so on and diagrams that are generated via output. So well over 500 pages of content if you were to just print it out. So there's some kind of trade-off, right? When a developer pushes, let's say, changes to one notebook, we don't need to test every other notebook to make sure that all the other notebooks ran. We just want to make sure that that one notebook continues to work. So we have a little hack for this when a developer opens up a PR. If the image, the code for imaging our environment has not changed, we just test the notebooks that have changed. And we also test those internal links again, because that's a really quick test. But we don't need to test the execution for the other notebooks. On the other hand, if they did change the image, well, it's a little rough. We got to make sure that everything works again in the new environment in case there's some kind of crazy dependency error that we haven't accounted for. Once they have made one push with a new environment, we cache that environment. Thank you, Docker. And then at that point, they're a little bit safer. Or it's going to run a little bit faster. We still test all the notebooks and local links, but at least they don't have to sit through the environment rebuild process again. So once that happens, then we kind of saw this bottom flow in the previous diagram. So I won't spend too long on it, but master gets pushed to, we run those tests, and then the build happens, provided that the master test pass. And actually, even once we build the DigitalOcean image, we also make sure that in the DigitalOcean environment, because this is a new environment, right, we make sure the notebooks run again there. And this is all really easy to do and easy to facilitate, basically because of that NB convert command from the previous slide. So that's sort of trick number one. Execute as little as we need to execute. Trick number two is just execute it in parallel. So all this code is talking about is that we use nose tests to run our tests. Nose tests and Nose's parallel plugin are a little bit weird when it comes to dynamically adding test functions. If you're curious about adding tests, then I would say talk to us after, and I'll kind of go through this sort of parallelization stuff. It's just a little bit of messy introspection that we had to do. So once we get to the deployment phase, once we've got everything working, everything's been tested, hopefully it's been tested relatively quickly and speedily, we deploy. And here's kind of what that pipeline looks like in terms of getting the information to students once everything is passed and is built. So on the left side of this diagram is basically everything I was just talking about, the testing pipeline, getting the materials to AWS, and the image to DigitalOcean. Great, we're there. What happens? Once an instructor or one of these folks who's been working on the course is going out to deliver some sort of training, whether that could be the fellowship, that could be the foundations course, it could be a corporate training event. We use the exact same pipeline here for all of this stuff. Once we get to that point, basically we have a web interface where you can specify the course modules that should be loaded onto the boxes that you're deploying. You then click a button, which triggers the DigitalOcean API right here to turn on as many boxes as we need. If we have 30 students, we're turning on 30 little boxes, one for each of them, from that base image that we built on our continuous integration server. From there, we do some of the last-minute provisioning steps on Chef. We automatically turn on the notebook server for people so that students don't need to worry about that. We actually used to make students go in and SSH in and turn on the notebook servers themselves. And this kind of makes sense for certain groups. Like we want the fellows to do that so they get a little bit more competent with messing around with the command line. In a 3-day training or really short workshop, that's just too much to be worrying about. So we automatically turn on the notebook server with them. We use IP tables to put it on port 443 and set up some really simple SSL certificate stuff. Once that's all taken care of, the very last thing is we just on each of those boxes, download the materials that we pushed to AWS previously that, again, are nice and tested, nice and ready to go. We just pull those in into each box, and we're done. You can imagine kind of in the bottom right corner over here, a smiling student interacting with this box. So that's pretty much it. And the last thing I really want to briefly mention here is Jupyter Hub. Hooray! We did our first test deployment of Jupyter Hub right here at JupyterCon in the 2-day workshops earlier in the week. It went quite well. We ran into a couple bumps. But as far as first deploys for new infrastructure, I would say it went pretty fantastically. The guide, thank you, UV and Co, is really wonderful. I would highly recommend playing around with it, and even just checking it out. If you're ever thinking about using Jupyter in an educational context, it's a really, really great solution. Our goal is to move basically all of the corporate trainings that we do, that foundations course and workshops over to Jupyter Hub. We'll still give the 8-week fellows those DigitalOcean boxes just because they're a little bit bigger and beefier for analysis work. But that's kind of the plan. And I think that's pretty much everything we have. Rob, did you want to add anything in conclusion?
Nope. I'll just point out this is us. The presentation is available online. It is a Jupyter notebook, so you can go get all of those links. So you didn't have to be carefully scribbling them down. And it sounds like we got 4 minutes for questions, so we're happy to take them now.
The link checking script. Oh, that's a good one. And I did forget to mention, we also sort of parallelize out the link checking, right? You wrote that. You wrote that initially, didn't you? With request features.
So.
Yeah. And then there was some terrible threading bug. But we don't have that. I can put up a gist for that.
We'll put up a gist, and then we can put a link to that in the presentation.
Yeah.
Question here?
Mm-hmm. Yeah, we just run a Jenkins box. Sure.
Where you are leveraging some widgets, and if yes, how are you planning to kind of do some tests?
Sure. That is actually a very good question. There are a couple places where we use IPy widgets to try to give some interactivity, and they're always breaking on us. In fact, they broke during the presentations this week because we had a new version of Jupyter out. I don't have a good answer for that. If anyone has good ideas, please talk to us because we can test that it runs. We can't test that it looks good yet.
And maybe browser testing or something. That seems like pretty heavyweight. But another great way to leverage widgets is Bokeh, if you haven't used it before. They bake a whole bunch of widget-based visualization into like a from Bokeh import notebook or something like. I forget the exact syntax, but Continuum Analytics makes it. It's a package called Bokeh for visualization.
You mentioned what developers have to do to add dependencies. Do you have situations where students want to add dependencies?
Sure. So right now, this is actually sort of done for us in a way because we're on DigitalOcean. So it's not like a Docker containerized environment where the environment is going to go away once they log off the way it sort of happens with Jupyter Hub. So right now, we do give students sudo at-level access so they can install any like Debian packages they need. They can also run a pip or conda install. As it currently stands, for Jupyter Hub, it's going to be a slightly different situation. Although the people who mostly want to do that, I would say, are the 8-week fellows who are going to keep on DigitalOcean anyway. So yeah, that's kind of how it works for us right now.
We have to give them the great power, great responsibility talk. And
we've had a couple of RM-RF/ situations.
I think we have time for one more. Everyone wants to go out to have coffee.
Yeah, please grab us for coffee afterwards if you want to talk about any of this. And thanks so much again, guys.
Take care.